Hello everyone. Unfortunately, because it's online conference, I cannot interact with you in any possible way, but I still hope you're good, you're in safety, and you're well. So, let me introduce myself. My name is Kyrylo. I am engineering manager in Perimatch Technology. I have about around 7 years of experience of building different web and not only products. And today I will talk about our design system approach in Perimatch Tech, about web components a little. So let me guide you to our introduction. So for whom will this speech be interesting? I think that you might be interested in my speech if you need to know something new or maybe just refresh your knowledge about design systems, about design tokens, about consistency in design, and so on. Then I should describe some news and some current approaches to build web components. I should clarify why we chose them. I should clarify why we stick with web standards and how it helps us, or maybe which disadvantages it provides to our workflow. And it might be helpful for distributed teams if you are working in different environments and different organizational parts of structure and so on. And of course, it's for complex and dynamic organizational structures when you need more consistency to keep it focused and to provide more features and the high level of the stability and the high level of the consistency. And it might be helpful for growing teams who just faced the crisis of growth when they also need some development lifecycle pipelines. They need also some conventions around these pipelines, and they also need some information about how to keep they balanced in the technology and the rush from the product managers and so on to keep it stable and configurable at all. So our agenda for today consists of some main parts. Firstly, I should describe you a background of our product and which challenges did we face before we came to design system and web components itself. So it will be a brief overview of the big picture about our company, about our development approaches. I should tell a little about our modular architecture. I should provide some details about our module federation approach, about how we deal with modules, why we stick to modulus, and why we stick to micro frontend architecture. Because almost everything in this life has happened for a reason, and the design system and the web components and UI kit are also have their roots. Then I'll go and guide you through our implementation of design system. I'll briefly show you which preferences it adds to us, which use cases it's opened for us, and we should check the component approaches that we implemented in our web design system. And not web design, it's about all products, so it's consists also of iOS and Android. And the last but not least part will be about web components itself. So we should clarify some discussing topic about it, we should talk about some controversial topics, why we also choose the web components, how it helps us, or maybe which disadvantages it provides to our development lifecycle, and how it might be useful for you in your products and in your teams. In this part about web components, I'll briefly guide you through the overview of the technology about main specification. It will be just an overview of main parts of web components, such as custom elements, shadow DOM, and templating. Yeah, so I should provide some information about technology at all, and then we go deeper to our hands-on experience and our own feelings about how to work with web components for today, how it might be easy or how it might be challenging in some parts, and where we faced some issues with it. So let's go. I think it sounds like a solid plan, so let's start. So, dear colleagues, audience, just for better understanding of our reasons and root causes of technical approaches and engineering solutions, I need to briefly guide you through our background and I'll show you high-level system overview just to make you more familiar with our needs and our requirements. So let's start from the roots, where it started. And as you can see on your screens for now, it's a common example of our application. It's one of our applications, to be clear. And as you can see from the first points of view, it doesn't seem complicated or complex too much. It's a single page application, fully client-side rendered, that consists of different UI parts on it, and these parts also are not very hard to implement. And probably you saw something like that 100 million times before all around the web. But the main interesting part about it is the number of developers and teams that developed it for now. And this amount is about 100 developers only for front-end part, and 15-20 teams about this. So it's only for the front-end part of pretty much applications. And it wasn't like this before. So when I firstly came to the Parimatch, I worked in a small team with amount of 15 members. And why I sell this small? Because they developed entire feature requests from all over the Parimatch. So we have a lot of different product managers, we got different requests, we got different features, and it was quite challenging for one team to handle this and to deliver features in this high amount. And in some point of time, everyone just recognized that it might be a risk, it might be a bottleneck. So one team cannot provide as much effort for such complex and a lot of requests that we had. And we decided to split it between different streams and, of course, hire more developers. So, as I mentioned before, it grows from 15 to 100 developers in the last 1.5 years. So, if we take a look for now at the picture, we should recognize that different parts of our applications are split between different groups of developers. So, between different streams and different domain expertise based engineering cross-functional teams. And it was quite challenging to split our monolith, because it was a monolith when it was one team, into small pieces of reusable modules that might be injected and embedded in the current web solution. So it's another topic how we did it, but I'll briefly tell you the basics. So, as I mentioned before, different teams in different parts of company for now responsible for different parts of application. And of course we faced a lot of requirements with it. So we need runtime updates, we need asynchronous releases, we need isolate scopes, we need to decouple our highly coupled monolith into smallest modules with their own scopes, their own isolated features. And also it all might be composable, so might consist of different parts and different layouts and so on. And we built it with a microfronts approach that maybe you heard about it also. For the last couple of years, I think it's hot topic. It's model federation of a Webpack 5 feature. And also we have a lot of JavaScript for today. And depend on it, we got some issues. So let's go from these points. Consistency of design, performance, reusability of components, customization, configurability, asynchronous and independent release flow, cross-component communication in the terms of our product in the context of one resource, and also versioning and versions mismatches control. So, as I mentioned before, we handled with Model Federation Webpack 5 feature. And if you are not familiar with it, I'll highly recommend you to read this book and get some example from the GitHub repository. It's baked by one of the main contributors and ambassadors from the technical world of JavaScript. And if you're not familiar, I should just take a little overview of this technology just to provide you information how we built our approach and why does it matter when it comes to consistency and cross teams communication. So firstly, we have, as I mentioned before, different modules that supported by different teams in different substreams, different part of our organizational structure. And also we have some integration layer that might called like shell. And it's probably the basics part of the module federation. So you need some host application that will connect all other modules into itself. And also you need to have different micro frontends. So if we talk about the basics, modules might be deployed on different hosts. And Webpack 5 module federation helps us to import them from different hosts. So by example, you have team A micro frontend that should be deployed to the domain A, and you have, for example, team B micro frontend, and they should deploy to the domain B. And also you have shell applications that might be hosted on the, let it be, domain shell. So you can, with Webpack 5 module federation, you can bundle and build your applications and host them on these domains. But in shell, you can just import them like the basic dynamic imports. I think that everyone familiar with it because it helps us a lot when we're creating some lazy loading, when we split our components into smallest chunks and so on. So with Webpack 5 module federation, you just can dynamically import the micro frontends and modules like basics modules on JavaScript with dynamic imports. And also they can, of course, import each other and so on. So, as I mentioned before, we faced also lags in performance. So, performance is a very, very important part of our product because, as you know, the average user of the mobile phone use the low-tier device at around 112 bucks in cost. So if you develop mobile first application, you need to care about performance. So how can you care about performance in the single page application world? Okay, of course we provide less JavaScript. So we need to provide less JavaScript when we build a micro frontend approach. Instead of using less modules, we can also share dependencies. So the module federation also provides us functionality to share dependencies. Let's also take it by example. For example, micro frontend A uses React of 16 version. Yeah, and the shell also uses React 16, and the team B also uses React 16. In the previous approaches of the micro frontends, you need to handle this code duplication by yourself. But with module federation, you just can declare that you have shared dependency in shell, micro frontend A, micro frontend B. So when it will be loaded at the page and the resource, they will recognize that, wait, I already have React 16 in the scope, so I do not need to load one from myself. And it's responsibility of our shell in our case, but it also may be extrapolated to another micro frontend. So if team A need React 16 and team B need React 16, but in shell maybe we on different page doesn't use React at all, but we can share React from team A with team B. So it's just basics of module federation and which problems did we solve with this approach. So, as I mentioned before, if you're not familiar with it, I highly recommend to read this book and get some examples from the GitHub repository. So let's take a look at our our pain points. So configurability, it's okay, we got it. Asynchronous independent release flows, it's also out the box, we got. Cross-component communications, we solve this problem. Versioning and version matches control, we also share it, resolved with our model federation approach. Also, few words about it. If you, for example, works with micro frontend that depend on React 16 and you have another React and shell and it's backward compatible with semantic versioning, I hope you're all familiar with it. It will be used the higher version of React, so it's fully baked with micro frontends, fully baked with model federation. And also you can flexible work with these versions. So it also part of improvements that provides with model federation. So you can just watch this repository. That's all that you need to know about model federation. Let's talk about other topics. So we got unsolved problems of consistency of design. We got unsolved problem fully in performance. We also got some problems with reusability of components because it's not a layer of the micro frontends. It's we need something else to reuse the components. So because one team can implement slider, but another team can implement same but different slider. Yes, so it can't break contract or maybe have different properties and that. So it's not about reusability. Of course, if you got common software development lifecycle and you got two teams communicated each other about the slider, they probably will share this one. But if you have, for example, one team in department A and second team in department B and they never communicate one with each other, they probably and mostly will have two different realization of sliders. So it's not about reusability. So which issues did we faced when we came to our micro frontend world? So a lot of complexity in the same things. So as I mentioned before, you can have different teams that make similar features but different. So they can have different buttons, they can different forms, slides, and so on. It's hard to implement global changes for now because if in the previous realization of monolith you can just change the CSS variables in the host application and everyone should handle it. For now, you need to go to each team and provide them requirements to edit in their own repositories. And also, it's likely a perfect place to solve it with some high-level abstraction that also will provide one similar approach to work with similar problems. And here we comes to our conclusions about this micro frontend approach and this type of organizational structure, that we got some overhead in so basic things. So we solved asynchronous releases, we solved issue with performance, we can load dynamically different modules and so on. We got almost common software development lifecycle, but when it comes to, for example, design in different teams, because they have their own vertical of products and so on, they can implement similar features in different ways. So how can we solve it? So what's the answer to the question? Is flexibility is converse to scalability, and maybe we should how we should solve this problem, how we can provide standard way of and common language for this amount of teams to communicate with each other in a common way. And the answer is pretty simple. It's implementing a design system, and it helps us to make consistent design and reuse some components between different teams without meeting madness. So no one likes to open the calendar and solve their 6 hours of communication around yet another form and yet another button and yet another, I don't know, any type of UI element that you had implemented before, but for now it might be changed. So the answer is simple, it's design system. So let's dive into design system and I'll quickly guide you through the basics of design system. Talk about design system a little bit more. What is a design system? It's a common and widely used approach that helps organizations and companies and different teams at any level of scale implement and provide unified visual language for their customers. And not only, so it opens a lot of benefits for us. Let's take a closer look. For example, firstly, if you implemented design system once, you can rely that all the design related work in the future will be done quickly. Why? Because it's simply reusable. So you don't need to reinvent the wheel once and once again. You just implement it once and then you can reuse it in your products. It also affects the developers. It's not about only design, because designers also can build a tool kit around it, or for example UI kit library, as we done in our case, and then just simply reuse the components from there. Also, it's provide a unified visual language, and while you're using, for example, Google or Apple, you might notice that all of their products looks familiar to you because they use design systems, and it scales and it provides a consistent design between different platforms. So you can have, for example, web application, native application, and I don't know, desktop, iOS, Android, so on. And all of these products between all of the platforms should be looked the same because they use common visual language, and it can be difference between, for example, user experience and UX interfaces, but the UI, it's always still the same, stays the same. So it also saves a lot of time for us because we don't need to discuss yet another button on yet another input form. We just reuse it from previous implementations. Okay, so how can we implement UI kit in our RTL company? Firstly, we decided that we need a cross-functional team with a high-level expertise in design that should provide conventions and also UI kit as a product for the entire company, for all the teams through our organizational structure. And it works well for us. So let's dive deeply into the main parts of the almost every design system. And this slide, I think it's perfectly shows the main basics of any design system. If we should take a look at from the left to the right, provides us different layers of composition. So at the left side we get less complex features and units, and the right side we got a more complex products, pages, and so on. And you can call it any name that you like, but the atoms, molecules, and organisms, I think that perfectly describe the basics of design system. So it starts from the left, from the main basics components that called subatomics in this case, but partially in our case we call them design tokens, and probably you also heard about it before. But we got some improvements in the design tokens approach. For example, if you're familiar with Google Material, they use the design tokens that calls like primary 100 and so on. So they stick to the colors, but we stick to the UI elements. So it's all because of troubles while we trying to read them, or for example provide new theme for our product, and it's hard to find where the primary 100 is used. So it's quite hard to figure it out where it will change. When you use namings and semantics of design tokens such as we do, you should clearly see where the design changes will be applied. So, more about the semantics. Firstly, we start from the color mode. So it might be light, dark, or whatever else. Then we add a component, so it's like light button, and at the end we add a state, so it's like light button hovered or light button disabled, and it helps us a lot while we trying to redeem or restyle our products. Also, we provide some automatization around it and provide some automatization tools. Firstly, I need to clarify that almost all of our designers works in the Figma. And the Figma provides a wide API to work with, and we write a plugin to get the design tokens directly from the Figma for our projects and then bundle it or deploy it as static assets to our infrastructure. And end-to-end, it seems like designer or product owner or someone who has access to our Figma can just simply change the values of these color tokens that I described before. And then it will be applied on our products almost simultaneously. It's not simultaneously, but it's quite fast. It takes, for example, 1 or 3 hours to just redefine tokens in Figma. And then with the next release of our UIKit library, we should see the changes on our applications. Of course, if we use the theme that describe it in the Figma. And for this, we use our CI tools. We use GitLab. So on the pipeline stage there where we built our application, we just go to the Figma with this plugin and take from there our design tokens and bundle it in our applications. So it's quite simple and straightforward way to update our design almost on the fly. Also, our designer and product team designed the tool that calls Token Master. It helps to unify and group the color tokens by the hex values. So it helps while we trying to implement redesign quickly, and we don't need to search in which parts of our application we used, for example, red color or yellow color. And here I should provide you some quick example of it, and the fast YouTube video from our product team will help me in it. So it also decreases complexity while we're trying to restyle or redeem our... Oops. Sorry. So it tries to implement our redesigning and redeeming faster. And as I mentioned before, because we provide our UIKit as a product and we need to some level of abstraction at the top of our main product, we just simply use these color tokens as CSS variables that attach to the root of our HTML element document. So it's quite easy to maintain, it's quite easy to update, and it's very good approach, I think, to provide CSS variable to entire application. And as a conclusion, the design system helps us not only stay consistent around different platforms, but also helps us to redeem and restyling our products faster. And you might ask, so that things that you showed, it's not coupled to the web components. So the CSS variables, the UIKit, it's same approach that we can use with any different frameworks and any different solution that provide us current state of web and modern front-end. So here it will be the part about web components, about our tries around web components, and in the next part of my speech I should provide more details about our approach and how it helps us, or maybe not so much, So let's go to the web components. One of the best part about web components is just they didn't try to compete it with modern frameworks, libraries, tools, and development approaches. Web components is just a set of tools and technologies that helps us to be closer to our native web API and web platform. So it provides a more standardized way to define our components, encapsulate their behaviors, styles, and so on. Before we jump into web components overview, let's quickly clarify our requirements once again. So consistency of design we are achieved already with the system design, with design system. Customization also, but we still lacking in terms of performance and reusability of the components. When it comes to performance, it's a very pain point for us because we are mobile first application and a lot of JavaScript hurts our customers a lot. As we know, probably the average device on the planet Earth is a $100 low tier device, so with not top tier CPU, and it takes a lot of time and force to just compile, parse, and show the application to our customers. So when it comes to UI kit and web design component and web design system, we try to fit the requirement of performance with choosing the web components and to scale it at a more complex level to our widgets and our pages and so on. So the main reasons, one of the main reasons that why we tried web components, it's of course performance and reusability of the components, because of course you can deal with reusability of components with, for example, conventions of common software development lifecycle between different teams, but it's not fully reusable components, because you cannot, for example, take a React component from one team and reuse it in another Angular application. So it's not a fully compatible and it's not a fully reusable. So for the next few minutes, I will provide a brief overview of the web components as a technology. We will describe of which part it consists of. Then we should provide some information about our development experience impressions and how it feels like, how it fits our development workflows to work with web components. And of course we will cover some drawbacks and issues that stop us from using it at full scale, not only in UIKit but also in other parts of our products and application. And we will end up with some conclusion about web components in our particular case while implementing UIKit, and our thoughts about the next steps and the future. So firstly, let me describe of which parts consists web components as a technology. So it's from the three main specifications. It's a custom elements, shadow DOM, and HTML templates that also can be slotted. And to build it, we need use ES6 classes, of course, to extend custom element from the HTML element. ES6 modules, it's quite widely used API. I think you always all heard about it and works with it every day. It's just to import our components in somehow place in different at some product. And custom events just to provide cross event communication between different components. So let's start from the custom elements. Custom elements is very the basics of the web components. It helps us to declare our own HTML element in the document. So you can write your own HTML tag that will act like just a common HTML element. Probably by itself, custom elements doesn't provide us any level of encapsulation, and from this interesting part that it can be also one custom element with the same name in the global scope. So you need to name your custom elements carefully just to prevent rewriting it, and it might be by convention be named with a kebab case. So We will briefly overview the lifecycle hooks of the custom elements later. So now let's go and overview some shadow DOM approaches that it provides us. The shadow DOM probably the most important thing because it provides us a lot of encapsulation. It's in few words, it's just a separate DOM inside your all just regular DOM. So it lives in the entirely separate environment in the DOM, and it fully encapsulated. It can reuse styles, of course, and it can be scoped in the terms of styles, of course. So you can just encapsulate all your styles and internal behavior into shadow DOM, and it will be 100% safe from the impact of the outer environment. So it provides high level of isolation and stability. Also, it provides a different way of recalculation styles, of course, because the DOM doesn't need to recalculate entire style for the old DOM. For now, it can be split between different shadow DOMs and the DOM itself. So it also impacts in the good way our performance. And the third one is HTML templates. HTML templates is just a document element that helps us to reuse our markup. So we can just define an element with template element, write some markup there, and then reuse it with around different web components. So what did you need to create a web component? Of course, we need to extend our custom element from HTML element. We need to define a template to write some markup there. We need to append template to the shadow root. Shadow root can be attached to any DOM element of the light web. And then we need to define component in the custom elements registry. As I mentioned before, you need to provide a unique name for the entire resource, and it should be by convention described as a kebab case, in kebab case. And after that, you can simply use it in HTML element. Of course, if you're following by this example, you will see the empty component because we didn't add something to our template. So here it is, how can we add some styles in it, and also we can see that we have some tag that calls slot. And it's another part of the features that provides us HTML templates. It's provides us a way to handle composition of the different elements and components in our different UI elements. And it's part of the HTML templates, as I said before. So you can define the slot. For example, here we can define the slot with name username, and then at the top, and when we use the web component, we can pass there some element with the also name of this slot. So it will be composable from the different elements that you passed into the component. And as I mentioned before, the custom elements provide us different lifecycle hooks and different methods that we can rely on. So first of all, it's of course constructor, then connected callback and disconnected callback. Connected callback triggers when the custom elements appends to the document object, and disconnect callbacks obviously fired when we removed our custom element from the document. Also, we need to clarify how to work with data in the custom elements. So for this approach, we can use attributes and properties. Attributes, it's just passed like standard HTML attributes, and it can consist only of strings. And to handle their change and to handle their values, we need to observe them with the observed attributes method, and also we need to clarify how we can react to it and the attribute changed callback. So it means that you need to handle data view updates by yourself. And in the case of properties, that also you need to handle all the data view binding by yourself, because even if properties can be used just different types and can be passed with different types and different data structures, data types. You just anyway need to handle it by yourself by getting these attributes directly from your class and set it directly into your class. And then you need to get some attribute change at callback to update and re-render your component. So at the end, the basic solution and the very common component that we can create from the scratch should look like similar to this. So we got some class that extends from the HTML element. We inherits in the constructor from the HTML element. We attach it to the shadow DOM. We on the connected callback we provide some template markup to this, and also we have here this connected callback that's empty. We just provide the list and enumeration of the attributes that we want to react on when they change, and we got one set and one setter and one getter for handling custom properties that can be passed from the for example browser itself, or you can use it in the code. So it's passed a property, and property can be for example string, object, so it can be any type. And the good part about it, because it seems for me a little bit complicated and it has a lot of boilerplate, so you need to handle attributes that you provide, you need to render every time component when it comes to update the attributes or properties. So it's a lot of boilerplate, and the good news and good point that you ain't gonna need to build it from scratch every time, because a lot of different solutions and market that provides you basic improvements in development experience. For example, you can use a stencil, lit, or svelte. You also supports custom elements, or Preact, or any great micro frameworks that allowed us to reduce boilerplate. So personally, we stick with lit because it's lightweight. It's around 4 kilobyte gzipped, and baked by Google, so it's X-Polymer. Maybe someone of you is familiar with Polymer. It was a quite common and quite popular framework in the past years. So the YouTube, for example, built on the Polymer, as I remember, and it's stable and in active development. It's for now a second version of the lit. It provides us a lot of development tools and development experience, increasing in the quality, because of they handle lit handles all of the boilerplate that we described here, with some TypeScript decorators and with some reactive approach. So we don't need to define getter and setter for each attribute. We don't need to define our internal state with our constructor and so on. We just can use our custom TypeScript decorators that provides by lit, and it will be works out of the box. So it also supports different attribute types, so we don't need to parse and handle types by ourselves. And as I mentioned before, it's TypeScript first class support out of the box, and also it works without TypeScript, but with TypeScript it looks way much better. So if, as you can see at the screen, it simply looks like many other modern framework. So let's discuss web components about in the terms of our approaches, and how it might help us or how it helped us in our workflow. So what we needed from the web components and how they can help us. It's framework agnostic. So if you read component once as a web component, you can reuse it in different environments with different frameworks. For example, you can have one page that written in the Angular and the second page written in the React, and you can just reuse your own web component between different applications without any issues with them, because it's fully isolated and it's compatible with just an HTML and web low-level API, because it's cause of reusability. So it's also stable and provides long-time support because it's official standard for now. So it helps us to not be worried about new version and about backward compatibility issues. So it's standard for now, so we can use it, and it's long-term bet and provide us a lot of improvements in performance. Partially in our case, we didn't recognize any performance improvements, just because we had a lot of overhead written before in the React and so other components, other libraries. And for now, it's the impact that provided by web components is too small to get some conclusions about it. But it helps a lot if we want to be fast in the terms of client-side performance and startup performance. Yeah, so when you just firstly open the page, it provides you less JavaScript if you will build your application with the web components, and it will be a lot faster than on JavaScript. And also it provides different approaches with recalculating styles in different shadow routes, so it also helps to reduce recalculation cycles for our document object model. So it also impacts our performance in a good way. And also it's a native approach to rendering, so you don't need a virtual DOM, you just define the template that might be native rendered, and it also positively improves your CPU usage, and it also positively impacts the mobile first applications. And of course it's provide a high level of isolation. You can rely on your web components in any environment that you will put it, and then for it, the nice case is if you develop some widget, for example, some pop-up with Net Promoter Score, you just can write in web components and you can add it any environment. It will not be broken by any other JavaScript on the page, and you just can rely that it will be 100% in functional requirements. I'm sorry. So you can rely on insulation and do not worry about impact of the outer world when you insert your web components in some products. And it's also widely adopted for the web for now and around the web, because a lot of large companies and high loaded platforms use the web components in their solutions. So why can't we? It's part of the integration experience. Firstly, let's clarify once again that we used React application, so we need some support from React to use custom elements, and for it we can go for the custom elements support website that I'll also provide as link in the attachments to the presentation, and then there you can find current state of the supporting custom elements by different frameworks. So in React it's quite set picture, but fortunately we have Lit React dependency that helps us to implement our adapters very fast and clear. So also we extended React typings because React doesn't support slots, And the integration in our current application was quite simple. It was very straightforward and simple. Our developers who came in the project, they were all React developers, and they just switched to the web components in just 2 weeks, from their words, of course. But it was very simple and easy to change the state of mind to the web component instead of React, because as you said before, it's very similar for now to current modern frameworks. And for tests, we are very passionate about the test coverage. We get around 95% of unit testing, so we need to provide a testing solution to our developers. And for the web components, the testing pipeline is similar to any other frameworks and tools that we used in the JavaScript world. So it's we use the OpenVC testing library, and it's very similar to Jest or other test runner that you are familiar with, and it's based on headless Chrome, so it works perfectly and it works fine. Also, we faced some issues with style isolation, but it's just a minor issue. There is an interesting thing about slotted pseudo class. When you use it, it might be overwritten by the entire document classes. So, for example, if you use some normalized CSS to just keep your paddings and margins same between different browsers, it will overwrite the slotted class that you can use to style the components that you use in slots, because the components in slots is a part of the light DOM. It's not a part of shadow DOM. So when you define the slot and you put it in the web component, the web component tries to find it in the light DOM, and then it's not copying the entire element there. It's just moving into the flattered tree of the web components. But never mind, it was a minor inconvenience. So the main drawbacks of the using web components for today. It's only one thing, and it's server-side rendering. You may ask, why you need server-side rendering? If you can rewrite entire application on the web components, the application will be fast enough to ignore the server-side rendering approach, so it might be enough to use client-side rendering. But we need server-side rendering in different ways and different approaches. For example, we need search engine optimization, and for the current state, we cannot rely on the small amount of information about Google crawler supports web components or supporting of the JavaScript execution, because even if the web crawler should come to our website, it might be long enough to build entire application, because we had a very complex application. It takes a lot of time to Googlebot to crawl it all the way from the bottom to the top. So we need server-side rendering to provide generated HTML to Google bots and for another crawlers to be more compatible in the search engine optimization. And how it will be resolved in the web components world. So as you can see, I provide the lit.ssr library mentioned, and that is why one of the reasons why we stick to the lit, because they worked around their own solution in the server-side rendering. And for now, unfortunately, it's still under development, but I hope they will end it soon. And headless Chrome, for example, render-drawn works in some cases fine, but we face some issues with headless Chromes in some part of our integrations, because, for example, we cannot rely on execution of JavaScript, and if we provide some custom solution around some headless Chromes or, for example, our own implementation of server-side rendering, we cannot rely that all the Shadow DOM API supported, and we can get the result that we expected to. So that's pretty much it about the drawbacks and about integration experience and about the entire world of the web components in our company. As a conclusion, I must say that web components is a promising and quite impressive technology that can be used even now if you don't rely on the server-side rendering too much. Partially for us it helps in implementing design system, and it's just another way to create components. The process of integration was clear and straightforward, so it's quite easy to integrate into your web components into your current products. And it's a long-term bet on the web standards and the standardized, bright future of the web. And we should make this bet. Thank you for your attention. I hope you enjoyed it. Bye-bye.